Alright guys, this is part 2 of the series for the free response questions, going into question 27 now. So we'll just get right into it. So here we have an equation that we want to solve in question A, where it has a bit of fractions in there and everything, but we're just trying to find the value of x. So we're just going to follow our basic rule of whatever's the furthest thing away from x is what we're going to get rid of first. So here we need to decide, are we going to get rid of the 5, the 2, or the 3? Well, we'll get rid of the 3 first by multiplying. This is saying divide by 3. So the opposite of dividing by 3 is times by 3 and times by 3. So we have 5 minus 2x equals 27. Once you got there, here we'll now subtract the 5 on both sides, because now that's the furthest thing away. So we have minus 2x equals 22. And then lastly, this is saying minus 2x. So that's saying negative 2 times x. So the opposite of multiplication is division. So we're going to divide by negative 2. Make sure you divide by negative 2 because we want to take that negative as well. We have x equals 22 divided by negative 2, which is negative 11. And that would be our answer. Whether you can check to see if your answer is correct very quickly, it's just substituted into the original equation and it should work. If you do 5 minus 2 times negative 11, that will give you negative 22. So if you're minusing, like, you got the double negative, so it'll be 5 plus 22 divided by 3. 5 plus 22 is 27. 27 divided by 3 equals 9. So that's just me quickly checking, but you could just substitute that into your calculator and it will give you 9, which is what you're expecting. So that's how you can check to see if your answer is right. Going into this next question here, we want to find the value of x to one decimal place. This is a right angle triangle where we're given an angle, a side, and we're trying to find another side. So this is basically a basic SOHCAHTOA question, basic, using sine, cos, and tan. In this case, we have this angle, so we want to use the adjacent and the hypotenuse. Okay, so here we have A and H, so we need to think SOHCAHTOA. Ka is going to give us this one, so we have cos of 38 degrees in 15 minutes. Equals, remember, adjacent over hypotenuse, so 15.6 over h. Now, this time we have the h on the denominator, so what you can't do is just multiply the 15.6 across and then that's it. Remember, whenever the h is on the denominator, the thing you're trying to find, you swap things around. So here we'll say h equals 15.6 divided by cos 38 degrees and 15 minutes, and when you put that into your calculator you get 19.9. Doesn't have any units, but it does say correct to one decimal place, so 19.9 to 1 degree. Again, making sure you read the question carefully. You don't want to lose silly marks because you're not reading the question. Also, you need to make sure that your calculator is in degrees mode, so you should see a capital D at the top of your calculator. I guess the most common mistake I saw with this one though was people multiplying the 15.6 across. Because the h is on the bottom, we need to swap them. Going to the next page, we have this graph represents the distance traveled by a team participating in 24 fundraiser. So we just have this line. We want to calculate the gradient of the line. So here we just need to pick 2 points on the line, any 2 points, and just do rise over run. What I'm going to pick here is, I guess, you generally want to pick 2 points that are on the grid at some point. Simply put, you can just pick this point and this point. Alright, so from here, I've gone up 25. Once I've gone up 25, I've gone across 5. So therefore my gradient is going to be 25 over 5, and when you simplify that, that equals 5. Okay, so that's just the gradient of the line, just rise over run. The idea is, no matter which 2 points you pick on that line, as long as you find the correct rise and the correct run, you're going to find the correct gradient when you simplify it to be 5. And so in this case, what does the gradient represent in this context? We're seeing that we're talking about distance traveled over time, so basically it's the speed of this team. So we just basically need that. What does the gradient represent? It means the distance traveled per hour guess you could also say also known as speed, like it's the speed of the walkers. So in this case, we could say 5 kilometers per hour. All right, basically you need to say something along those lines. You just need to say the gradient means speed, all right, or a rate of distance per hour. Going into this next question, we want to use the formula to find the value of t correct in one decimal place, and then we get given a bunch of different numbers. This is very similar to a question that was in 26, where there's no real tricks to it. You just need to make sure that you're putting into your calculator correctly. So here we have t equals 2 times pi times, and then what happened there? Times, and this is where it gets a little bit trickier to put in the calculator, but still just doing the same thing. So you do a square root sign, and in your square root you press a fraction sign, and then we'll replace the L with 1.2 over, and then G plus M, so 9.8 plus 0.6. And so just make sure you're closing everything properly. When you put that onto your calculator, it gets saved to one decimal place. So when you put that all in, you get 2.1 to one decimal place. Again, no real tricks here. I guess the only difficult bit here is making sure, first of all, you read the question carefully, and then also putting the numbers into your calculator correctly to get the right answer. Going into this next question, here we have this scatter plot showing the life expectancy at birth compared to the amount spent per person in healthcare in these 7 countries. We'll just have this here, and using a ruler, we want to draw a line of best fit by eye on the graph above. Now, it's going to be tricky for me to do this question with a ruler because it kind of stuffs up the smartboard. So you're going to have to bear with me by this. But this is done fairly well throughout the class. The main thing you want to do is when we have a line of best fit, it's just a straight line going through, so we're not just connecting the dots, just drawing a straight line going through. And generally the idea is you want half the dots to be above the line and half the dots to be below the line. Now, seeing that there's an odd number of dots here, that means we'll probably need the line to go through one of the dots so that there's 3 above and 3 below. So there's not just one correct answer to this. I guess there's like plenty of different correct answers to this, but I mean, you could draw anything that kind of looks like that. So see, notice that there's like 3 dots above and 3 dots below, because there's like an odd amount. That means I should probably go through one of the points as well, just to keep it balanced. But yeah, if yours doesn't look exactly like that, basically you just need to draw a straight line using a ruler that looks fairly good going through it. Okay. And what we need to do here is describe the data shown in terms of correlation between the 2 variables and comment on the relationship between the life expectancy at birth and healthcare spending in these countries. So this sounds like a kind of a big wordy question. You're like not really sure what this means. But basically what it comes down to it is you just need to comment on the correlation. So first of all, just looking at these dots and comparing it to our line of best fit, we see that all the dots are pretty close to that line. They're going in a pretty same direction. So not only are they going up, so therefore it's a positive correlation, but because all the dots are pretty close to that line, you could say it's a pretty strong correlation as well. So you could say, first of all, that it's a strong positive correlation. Strong positive correlation. And so what that's done is we've described the data in terms of correlation between the 2 variables. So we've done that bit, and now we need to comment on the relationship between the 2. So what we need to say here is, because there is a strong positive correlation, that means that as more money is spent into healthcare, the higher life expectancy at birth there is. So you're just explaining that as one thing increases, the other thing increases. A common thing that I noticed, and I kind of marked incorrectly because of it, people started talking about age, like as people's age gets higher, they spend more in healthcare, which does make sense, but we're not talking about age here. There's a difference between life expectancy and age. Okay, age is your current age, whereas life expectancy is the age that you're expected to live to before you die. What we need to say something along the lines of as more money is spent on healthcare, the life expectancy increases, which makes sense. Like, as we went higher along the graph, we went further along the graph. And you could say the opposite as well. Like, you don't need to say in that order. You could also say, as the life expectancy at birth increased, we noticed that the amount of healthcare spending also increased. Basically, as you can see, it's one thing is increasing, the other thing is increasing. That's all you really need to do there to tick off the next bit. And going on to this last page for question 27, and this question's a bit of a pain, this one, to be honest. So we have this credit card, tells you that you have an interest-free period of 40 days. If you take the cash advance on this card, he is charged daily interest at 18.6% per annum. The interest is calculated to include the day of the transaction at the day and the day which is paid. And then we have like basically the transactions for this month. So he wants to pay his account balance, including the interest in full on the 31st of August. So how much will he owe? So basically, we see that at the start of the month, he had nothing in that account. So like he had nothing to pay off. So everything we see on this table is everything that we need to pay. So first of all, what we can do is let's just focus on everything that's not a cash advance. Because if you read the question carefully, we see that this percentage bit is only charged on cash advances. If there's any purchases or payments, it doesn't apply. This interest doesn't apply. So let's just go ahead and find how much that is first of all. So I'm just going to call it the base, like with no interest or anything, and that's going to be that $97 minus that payment, because what he did is like he's gone and bought something for $97, and he probably couldn't pay that all back 3 days later. But he was able to pay $50 of it back straight away, plus 125, plus 58, and that gives you $230. So straight away, that gives you, $230 that you need to pay back. But this isn't including the cash advance. Now, what you can't do is just add that other $200, and then that's it, because we haven't accounted for the interest. But what I also notice people doing is they then added that $200 and then calculated the interest on the whole $430, which is not what you want to do. Like I said, the cash advance, only the cash advance is impacted by interest. So what we need to do here is we see that the cash advance was done on the 15th of August, and we paid it off on the 31st of August. And we're also told that this is calculated to include the day of the transaction and the day which is paid. So we need to think about, well, how many days is it between and including the 15th of August to the 31st of August? And that turns out to be 17 days. You could just count them in your fingers if you want. Like 1 is the 15th, 2 is the 16th, 3 is the 17th, so on until you get to 31st, and it'll give you 17 days. So what we'll do now, and this is where there's a bit here and there. I use simple interest for this, but other people use compound interest. And in fact, in HSC questions and the marking criteria for these, it uses simple interest as well. So I'm just going to use simple interest. But I know some other textbooks and some other people use compound interest. My general recommendation, just based on past HSC solutions, just use simple interest for this. So here, we want to find the interest on the advance. So the interest will be that $200 that we took as a cash advance, so that amount, times it by, and the other thing we need to do here is we're not increasing 18.6% per day, it's per annum. So we're going to get that 18.6%, so 18.6, we're going to divide it by 365 because it's so many days, and then over 100 as we normally do for percentages, or times that by 17, which equals $1.73. Okay, so that's the amount of interest that was on that cash advance, but he still needs to pay that cash advance as well. So therefore, the total amount that he needs to repay is at $230 plus the actual $200 of that cash advance plus that $1.73, which gives you $431.73. So 3 marks there. So basically, depending on where you got up to in this question, you get 3 marks. There's kind of quite a few variables in here for when marking. And then lastly, Susan is concerned about the weight of a dog, so she recorded the weights of 7 other dogs of the same age and breed. We have all these numbers. Now, you might notice straight away by looking at those numbers that one of those numbers is quite different to the rest. Alright, that would be the 102 kilograms. That's a massive dog, by the way. So Susan used this information to conclude that her dog, which weighs 45 kilograms, is an average weight. Well, the reason why she managed to do that is if we just found the average of those 7 things, so the mean with the 102, so the outlier, that does equal 45 kilograms. So what this person is doing is saying, oh yeah, well the average weight is 45 kilograms. Yeah, if you add a 102 kilogram beast. So if we don't take that outlier into effect, then we can, kind of find what the actual average is. But we need to first of all prove that it is an outlier. So using mathematical calculations and reasoning, so basically that's saying prove that it's an outlier, which takes into account any outlier. So that was like a big hint in the question saying, hey, there's an outlier here, show it, and therefore think about what happens without the outlier, determine if Susan's conclusion is valid. I mean, because the idea is, if we were to take out that 102 kilogram dog, the average is probably going to go fairly lower, and that would mean this dog, which weighs 45 kilograms, is actually quite heavy. In fact, heavier than all the other dogs. So what we need to do to prove that this is an outlier, and seeing that we're only looking at the top, we need to only look at the upper outlier. So the upper limit, I'll just write the formula first. The upper limit, that equals to the upper quartile, so Q3 plus 1.5 times the interquartile range. So let's just go find what those things are. So looking at these 7 numbers, here's our median, and therefore if we're looking at the median of these 3 numbers, the upper quartile is 44. And then also looking at these lower numbers, the lower quartile is 28. So that means looking at the interquartile range, so the interquartile range is going to be 44 minus 28, so the upper quartile minus the lower quartile, which equals 16. So now we have the interquartile range, and we also know what Q3 is, so therefore the upper limit is, what was it saying? 44, the upper quartile, plus 1.5 times 16, which equals 68. So what we're saying here is that's the upper limit. Anything larger than 68 kilograms is going to be an outlier, which we can clearly see that 102. So you can't just assume that it's an outlier, even though it's quite obvious. You do need to prove it, okay? So therefore, 102 kilograms is an outlier. So now, the idea is, if I were to take away that 102 kilograms dog, and if I've now found the new average, so then I would add up those numbers and divide by 6 now. We're not dividing it by 7, we're now dividing it by 6. So therefore, the new mean would equal 35.5 kilograms, which makes sense. Like I said, we've taken away this massive dog. That's going to bring down the average quite a fair bit. So therefore, Susan's dog is above average, and therefore, we can say that her conclusion isn't valid because her dog is nearly 10 kilograms higher than the average, so not very healthy. Anyway, so that's the end of question 27. Hopefully it was useful. Like I say, I probably won't get into question 28 and 29 and 30 tonight. I'll probably get onto that tomorrow night. So hopefully this will keep you going in the meantime. Yeah.